Okay, so today we're going to talk about different forms of quadratics. So, quadratic functions, different forms of them. So, before we do that, let's review a little bit of factoring, reverse FOIL, which we've done a lot, but it's been a hot minute since we've done it. So, let's go over. So, when we reverse FOIL, we are going to find what multiplies to this number and adds to this number, right? It adds to this number but multiplies to this number. So the question is, what two numbers add to 8 but multiply to 12? So if you get stuck, you look at 12 and you say, okay, what are the factors of 12? 1 and 12, 2 and 6 multiply to 12, 3 and 4, right? Which of these two numbers, when you add them, give you 8, and it's 2 and 6. So this becomes x plus an x plus 2 and 6. That's factored. Let's do the next one. I challenge you guys to do this on your own, right? So what two numbers multiply to negative 21 and add to positive 4? So I'm going to just look up the factors of 21 in general, right? So it's going to be 1 and 21. 2 doesn't go into it. 3 and 7. That's it. So you don't have many options here. This is not it, because this, if I even add them, they become 22. If I subtract them, it becomes 20, so it's not 4. If I add these, it becomes 10, but if I subtract them, I get 4, right? So that means when this is negative, remember, when this is negative, it's going to be a x plus and x minus, because a positive and a negative number give you a negative when multiplied together. So which one is going to be positive? It is always going to be the bigger number gets this sign. So it's positive 7 minus 3. 7 minus 3 is positive 4. So it's going to be plus 7 minus 3. Nice little factoring review. I mean, there's other methods of factoring that we went over, but this is the most commonly used. So let's talk about different forms, okay? And this is what we're going to be basically discussing for for a little bit of time. So in general, there's standard form, there's vertex form, and there's factored form, okay? Standard form is y equals ax squared plus bx plus c, okay? Vertex form is y equals a times x minus h squared plus k. And factored form is y equals a x plus m and x plus n. Actually, I'm going to put x minus m and x minus n, where m and n are your roots. So let's do an example. So, because I think it's easier to discuss something in an example. But the first question I have is, besides x and y, what do all three of these have in common? They all have the same a value. So if a is 1, it's 1 in every single one of these. If a is 25 or 1 over 25, it's the same thing in each and every single one of them. Okay. Now, what is, if I have an example, so I'm going to give you guys an example. We're going to use this example right here. So if I have y equals x squared plus 4x minus 21, where a equals 1, b equals 4, c equals negative 21. Okay? Now, in factored form, we just found it. It's y equals x plus 7 and then x minus 3. Now, what is it in vertex form? I'm just going to give it to you. So it's y equals x plus 2 squared minus 25. Okay? We discussed that all three of these forms are different in each and every one of their ways. We went over vertex form first, so it's been a while since we've discussed it. But let's talk about what each one of these forms give you automatically. Okay? Just by looking at it, you don't have to solve for anything. What do each of these give you automatically graphically, right? So let's do vertex form because it's literally in its name. What does vertex form give you immediately? It gives you the vertex, right? This is what vertex form is best for. It gives you the vertex. It's also pretty easy to solve for the roots because when we went over the square root property in the last phase, that you can add 25, take the square root of it, and then subtract 2 from it. So that it's pretty easy to find the roots, but the vertex is where it's at because it's called vertex form. So the vertex is what you will get from vertex form immediately. Factored form. What do you get from factored form? Well, we know that when it's factored, we can use the t-chart and get what? And get our roots or our y-intercept. So I'll say roots slash, not y-intercepts, x-intercept. Immediately, we can get our roots slash our x-intercepts because you just set each one of these equal to 0 using I'll write this here, 0 product property. And then what do we get automatically when we have standard form is we get the y-intercept. Remember, your y-intercept is your c value. So for this one, it's going to be negative 21. Okay, so each one of these forms give you a different thing immediately. Can you find everything else from that? Yeah, but it gives you one thing immediately. So let's do that here. Let's just fill in this chart, just these things, right? So the y-intercept of this function is going to be negative 21, or more specifically, it is going to be, because x is 0, 0, negative 21. So for here, the vertex of this function, same function, remember, they're all equivalent functions. And I actually put it here on Desmos for you to see that these are the three things that we just wrote out. They are the same thing. Notice how it's just changing colors? They are the exact same function, just different forms. Okay, so the vertex here is going to be h k, whatever hk is. So here, h is going to be the opposite of this, which is negative 2. Where's vertex here? Negative 2, and it's going to be the regular of this, not opposite, so negative 25. And then my roots here are going to be, and I'll go to the side over here and do the solving. So I have x plus 7 and x minus 3, and I set it equal to 0. So it's x plus 7 equals 0, so x equals negative 7, and x minus 3 equals 0. I add 3 to both sides, and I get x equals 3. So my x-intercepts, so I'll even put it here. I'll put roots are x equals negative 7 and 3, but my x-intercepts are negative 7, 0, and 3, 0. And if we look, we have negative 7 and 3 are our x-intercepts. My y-intercept is negative 21, and negative 2, negative 25. It matches over here.